Hey, good afternoon, Dreamforcers. How's everyone doing today? Just quick show of hands. How many of you are here for the very first time today? Awesome. Same here. This is my very first time at Dreamforce, so I'm super excited to be with you all today. My name is Alec. I work as a technical consultant for a Vancouver-based consulting firm called Groundswell. And I've been working with the Salesforce platform for about 2 years now, and a lot of that time has been involved with Lightning component development, which leads me to my talk today about JavaScript testing with the Lightning testing framework. Just a quick note before we start, you should only base your purchasing on decisions based on products and services that are currently available today. So with that being said, I kind of like to set the stage by first talking about the evolution of Lightning components in terms of really how far and powerful Lightning component development has come in the past couple of years. So at Groundswell, our custom technical niche is to create custom technical solutions for customers that want more out of the box. And what we've seen over the past couple of years is that clients are increasingly demanding more complex and bigger Lightning component apps. And we see this mainly in two different focus areas. The first being the implementation of Lightning communities within Communities Cloud, and the second being the development of Lightning apps to be used with Lightning Experience. And just to give you an example of the kind of stuff we've been doing, the latest implementation I was involved in was to create a custom brand community to be deployed to over 50,000 of our clients' end users. So I think this really speaks volumes in terms of the maturity of Lightning components and the increasing reliance our customers depend upon it in terms of what they expect out of the Salesforce platform today. And so as the size and the complexity of their apps grow bigger, we start to look at ways in how we could try to maintain the code quality of our Lightning components the same way we maintain the code quality of our Apex. So the first thing we started to look at was what Salesforce provides out of the box in order for us to gauge the quality of our code. And I'm sure all of you are familiar with the Apex testing framework in that Salesforce provides us with tools to unit test our Apex and a runner for us to run those tests and see what's passed, see what's failed, and see the code coverage. But the problem is there's nothing out of the box right now for us to be able to use to unit test our Lightning components. So the next thing that we started to look at was what tools are available outside of Salesforce that developers are already using right now to unit test their JavaScript. And it turns out there's a lot of really good tools out there already. If any of you are familiar with other client testing frameworks, maybe you're familiar with a couple libraries called Jasmine or Mocha. But the problem is that these libraries don't exactly work out of the box with Lightning components because Lightning components run on the Aura framework. And so there is a way for us to be able to use these tools like Jasmine and Mocha, which are already being used by developers with the Salesforce platform. I'll give you a big hint on what that service is. It's in my session title. And in case you've already forgotten, the answer is the Lightning Testing Service, or LTS. And what LTS is it's a managed package developed and released by Salesforce that provides a wrapper for us to integrate existing client frameworks to be used with Lightning components. And I kind of want to give an emphasis on the term wrapper in that LTS doesn't aim to reinvent the wheel and provide us with a whole new way of testing JavaScript. All LTS aims to do is to provide us the resources for us to be able to use what developers are already using industry standard today with what Salesforce provides. And so there are a couple key features I wanted to point out that LTS provides to us. First off, LTS is supported with Jasmine.js and Mocha, which are two of the most popular client-side testing frameworks today. Second of all, LTS is being able to use within a DX context or a non-DX context. But in the next later slides, when I show how LTS works, I really emphasize you to focus on how we can use LTS within a DX org, because I think you'll get a lot more functionality and a lot more power out of this tool compared to if you use it outside of DX. And the third thing I want to point out is that it's not really a feature per se, but I think testing Lightning components with LTS is obviously different than testing Apex, but it's quite similar. And so I would say that if you all are familiar with how to test Apex, I can almost guarantee you by the end of the session, you'll have the confidence to be able to test Lightning components with LTS. And so, kind of to reinforce that last point, I'd like to walk through the end-to-end flow of how we can use LTS within our dev flow, starting from when we first create our actual Lightning component to when we write unit tests for it for a JavaScript test suite, and to finally to run those tests. So, let's get started. I have a simple Lightning component I've written up here, and all it is a stopwatch component. And this stopwatch, like any other stopwatch, has the same core requirements of being able to, let's say, start the stopwatch to start counting the time that's elapsed, to stop the stopwatch to stop the time from being counted, and to reset the stopwatch so that the time counted resets back to 0 and the stopwatch stops counting. And so this short video is what the stopwatch would look like for an end user. If you look behind the scenes into the actual component itself, I've highlighted a couple key things to take a note of as in our next couple steps to keep in mind of when we actually write our JavaScript test suite. The first thing I have highlighted are a couple of methods that I've exposed through the Aura method tag. And those just correspond to the 3 buttons I showed you before, which is to start the stopwatch, to stop it, and to reset it. But I want to especially point your attention to the next 2 highlighted bits, because these are the 2 bits which we'll be focusing on when we actually do our unit tests. And these 2 highlighted bits correspond to the 2 things in which we can assert against when we do our JavaScript testing. The first thing I've highlighted are a couple of Aura attributes. And these Aura attributes represent the state of our component as we interact with it. So for my stopwatch component, I have 2 attributes. One is called isStopwatchActive, which basically just tells us if the stopwatch is running or not. And the second attribute I have is total MS count, which basically just tells us the total number of milliseconds that have elapsed since I've started my stopwatch and started counting. So that's the first thing we can test against, or attributes. The second thing I've highlighted are a couple of spans I have in the markup in my HTML, which basically just represent the hours, the minutes, the seconds, and the milliseconds components of my stopwatch. And so that's the second thing we can assert against, are the state of certain DOM elements within our markup. So now that we created our Lightning component, it's time to actually install LTS into our org. And we can do that in one of 2 ways. On the left-hand side, if you are using DX, it's as simple as running one CLI command called forest lightning test install. All you have to do is run that CLI command against your Scratch org, whatever org you're using, and that's pretty much all there is to it. That one CLI command will automatically install the unmanaged package for you. On the right-hand side, if you're not using DX, all you have to do is go to the GitHub repository for LTS, go to the releases page, and choose if you're using Jasmine or Mocha as your testing framework. Choose one of those links, copy the URL, go to your org, and copy and paste it to manually install the unmanaged package. So whichever way you cut it, it's pretty simple. Copy and paste or one CLI command. That's all there is to it. After we've installed LTS, it's time to actually get into the nitty-gritty and to write our JavaScript test suite. And right now, I have 2 things up on the slide. On the left-hand side, I have my actual JavaScript test suite for my component, which I've named stopwatch.cmp. And on the right-hand side, I just have an empty Apex test class. And that's just there to illustrate the key similarities between how you would write an Apex test class compared to how we would write a unit test for your Lightning component. So let's go through it step by step, starting from top to bottom, and analyze what's similar, what's different, and how we can write the unit test. The first thing to note here is that for Apex, for all of our unit tests, typically we would group them all within some sort of class. The same concept applies in JavaScript. We would group all of our unit tests, and in JavaScript we would call them specs. Specs are analogous to tests. We would group all of them inside something called a describe function. And just one quick note before I begin. What I'm talking to you about, these tests are written within Jasmine, But if you do decide to use another testing framework such as Mocha or anything else, I think you'll find that a lot of the testing terminology and a lot of what I've written here is very easily transferable. So the syntax you see here can still apply to whatever testing framework you do end up using. So going back to this example here, all of our JavaScript specs are encapsulated within a describe function, which is kind of odd sounding, but if you take a step back and if you think of it in terms of just plain English, our JavaScript test suite is essentially describing the functionality of our stopwatch component. And that's pretty much all there is to it. The next thing to focus our attention on are a couple of helper methods which also exist in JavaScript that we might be familiar with in Apex. So in Apex, we can have a test setup method which runs before every test class to do some sort of function such as setting up our test data, so on and so forth. And we have the same kind of mechanisms in JavaScript in that we can have a before each or an after each, which are just two anonymous functions that run before and after each test spec. So let's go into our actual test spec itself. In Apex, when we write our unit tests, typically what we would do is have some sort of void method and annotate that with the isTestFixture, and then do some number of assertions inside the test method provided by the system library. That same structure is very similar to how we would structure it in JavaScript, in that our test fixture in JavaScript is annotated by just an it function, which also sounds kind of funny, but if we think back to just plain English, remember how I described the describe function. So when we're describing the functionality of stopwatch.cmp, we can basically say that it, being the stopwatch component, resets the count back to 0 after the stopwatch is reset. And that pretty much just tries to illustrate the functionality or the key requirement of the Lightning component I'm testing. So that's all there is to line 11. We're just saying that it, being my stopwatch component, should do this some sort of functionality. If we actually go top to bottom in this test spec, I won't go over what each particular variable does and what each specific function call does, but I'll give you a good idea of how this test is structured because all the specs you can expect to write with LTS generally follow the same structure. So the first thing we're going to do for our spec is to utilize $T, which is a global variable helper provided by LTS, kind of analogous to $A for the Aura framework, in order to dynamically create our component for us to be able to work with. That covers line 12, and after we've dynamically created our component, we're basically going to simulate some sort of test scenario, and after that scenario has been simulated, do a number of expectations, which are analogous to assertions. So my test scenario for this specific requirement is going to be that I'm going to start my stopwatch, I'm going to let the stopwatch run for 1 entire second, and then I'm going to reset the stopwatch. So after that scenario has been done, I'm going to be doing my expectations starting on line 17. So recall from the previous couple of slides, I said that there are two main things in which we can assert against or do our expectations against in JavaScript. And the first one would be our Aura attributes. So that's the first thing I'm going to be doing my expectations on. When I reset my stopwatch component, I would expect that my stopwatch should not be active. And so is stopwatch active should be false in this case. And the second thing I would expect is that when I reset my stopwatch, the time elapsed should be 0. And so I'm just asserting that the total milliseconds elapsed or the total MS count for my attribute is equal to 0. The second thing in which we can do expectations against are certain DOM elements within our Lightning component. And so for the end user, when I reset my component, I would expect that when I see the stopwatch on my computer screen, it would show 0 for the hours, 0 for the minutes, 0 for the seconds, and 0 for the milliseconds. And that's what lines 20 to 27 are doing. We're just expecting that the span elements representing each of those elements which show our total milliseconds elapsed will just be 0 to our end user. Once we've done our expectations, we just simply say we're done. And that's pretty much all there is to a JavaScript spec. Just for time's sake, I've shown you this one spec. A complete test suite, at least for my stopwatch component, would maybe have 5 or 6 other requirements. But I think that this spec in general really shows kind of the key structure and the things you would expect once you start fiddling around with LTS yourself. So now that we have an actual JavaScript test suite, we need to find a way in order to run those JavaScript tests in order to see if they passed or they failed. So in order to create a test runner app, we're going to utilize a Lightning component provided for us by the LTS unmanaged package. Because I'm using Jasm as my test framework of choice, I'm going to use something called LTS_Jasm runner, provided by LTS. And as an attribute, test files, it simply takes a list of paths to my JavaScript test suites. So the file I showed you beforehand will exist as a static resource and as a JavaScript file called stopwatch.js. And I'm simply going to feed the path to that static resource to that Lightning component. Once we've done that, we basically just put that Lightning component, Jasm runner, into an Aura application. And that's pretty much all there is to it. So we have a test runner app now, and the final step is to actually run our tests. Running our tests, if you're not using DX, since we just create an Aura application, we can simply push that to whatever source org we want and navigate to the actual Aura application, and it'll run all our tests in a nice UI. But if you are using DX, it's even simpler than doing that, because we can utilize one CLI command called force lightning test run in order to get all the coverage and all of the metrics that we want on our console. And this is what the screenshot here is showing. By running this command, we can see exactly what specs have been run, if they passed and if they failed, and exactly how much time it took. And that's pretty much all there is to it. We just went through the entire end-to-end flow of how to create our Lightning component, how to write a JavaScript test suite for a component, and to actually how to run those tests in just under 10 minutes or so. So if we now take a step back and try to look at the bigger picture of how LTS can help your organization, I think there are 2 main use cases, at least us at Groundswell have thought of. And the first one I have up on the left is, I think, something you're all familiar with, because for regression testing, at least for the Salesforce platform, when we push our Apex code from, let's say, a sandbox to production environment, Salesforce will automatically run all of our tests and will only deploy our code if everything's passed and if we have the correct amount of code coverage. So we can apply that same concept to be used with LTS. And this is where I reiterate that if you really want the full functionality of this tool, to really try to use it within a DX context. Because maybe just thinking back to that previous CLI command where we can just run one command to run all of our tests. We can use that command with some sort of continuous integration tool like Jenkins in order for us to automatically run all of our Lightning tests whenever we do, let's say, a commit to our branch or if we do a deploy. And similar to how we do this in Apex, this really helps to save time and money down the road by catching problems early. And the second use case would be in the context of packaging. And so I think that if you're a software provider and let's say you have some sort of managed package and it's heavily reliant on JavaScript, and especially if you monetize that specific app on the App Exchange, by showing you go the extra mile to write unit tests for your JavaScript, I think it really shows that you care about code quality. And by showing that you care about that code quality, you're going to help to build customer trust down the road. And so just a couple keywords before I wrap up. There are a couple things just to be aware of before you start using LTS. And I think the biggest thing to be aware of is that LTS is not recommended to be used in a production instance because of the lack of a transaction wrapper. That's a big statement, but essentially what that means is that, let's say your Apex test class, you're to do some sort of DML statement like an insert of a case or deletion of an account. You can expect those changes to be rolled back after the test is complete. But let's say in your LTS test suite, your component does some sort of action and your controller does a corresponding DML statement. Those actual actions will not be rolled back at the end of your tests. And so the implication, at least for production org, is that you obviously don't want to mutate any live data. And there are a couple ways around this. First and foremost, I think obviously we just run our LTS test cases within a Scratch org instance, so that doesn't matter. Or if you're more comfortable with more advanced use cases, Jasmine and Mocha does provide tools to help mock certain controller actions, similarly to how in Apex you would mock a callout, so you won't actually do anything on the server side. And the second thing to be aware of is that LTS does not provide any kind of code coverage metric. And I think that's just important to note if you do use that kind of coverage in order to gauge the code completedness of your unit tests. So that wraps up pretty much all the content I wanted to share with you today. Just a quick recap of what we've talked about. I've gone through over what LTS is and how to use it within your org. And if you're interested in this tool, I really highly recommend you check out the official GitHub repository, because that's a really great place in terms of getting a lot of really good examples of different test suites and different components which the authors have released. I've briefly gone over some things about Jasmine and Mocha as test frameworks. And if you're interested in JavaScript testing in general, maybe if you've never done it before, or if you want to learn more advanced use cases, the documentation there is a really good place to look at. And if you do want access to these slides, all you have to do is download the Dreamforce app in order to download the session slides for my talk. One last challenge I have for all of you when you leave today is to go back and think of some sort of Lightning component that you developed in the past and try to test it with LTS. Because I think that even if you're not convinced that LTS can help you in your everyday dev workflow, I can almost guarantee you by doing this, you're going to learn a lot about your own code and how to make it more testable. So that pretty much wraps up all of my slides. Thank you all of you so much for attending my session today. And if you have any questions, I'll be around. Thanks.